Section 11.1, our first chi-squared test, the goodness of fit test. We use this test to answer this question. Is the hypothesized distribution of one categorical variable is the hypothesized, which we'll state in H0, is hypothesized distribution of one categorical variable. We'll have tests that deal with more than one later. One categorical variable for one population, and we'll talk about for more populations later, for one population valid. And that's what the chi-square goodness of fit test answers. So the test statistic, the chi-squared test statistic, chi-square, and it's represented by this symbol, chi-squared, tells you how far. By itself it doesn't answer the question, but it helps us get there. Chi-squared tells you how far the observed counts are, which are integers, observed counts are from expected counts. And the expected counts do not need to be integers. And that's what it tells you. The formula is given to you in your formula card, and it is this. Chi-squared equals the sum of all of the observed minus expected squared. Observed minus expected squared over expected. Over expected. Okay, so you get chi-squared, and then using chi-squared and the degrees of freedom and your calculator, you can find the p-value and determine whether to reject H0 or not. So chi-squared, the degrees of freedom, they're different than what you're used to, okay? Degrees of freedom is not based on the sample size. It is not. It's based on the number of categories. So for the M&Ms, it would be the number of different colors there were, which I don't remember off the top of my head. It would be a number of categories minus 1. And so it's not the sample size minus 1, it's the number of categories minus 1. And then you can use table C, which I'll show you in the examples in a second, but table C is not given in your formula card and is not as precise. So you could use table C, or what you would do on your calculator, which I would recommend more, to find the p-value, you would use chi-squared CDF. You're gonna see this pattern and you'll get used to it. So you'd use chi-squared CDF, and you would give it your chi-squared test statistic that you computed. And then you want to know the probability, you want to know the area under the curve, which is the probability that you would get the sample that you did if H0 were true. And that's chi-squared to infinity, and then you give it your degrees of freedom. So it looks a lot like TCDF, but it's chi-squared CDF. And so that's the process, which we'll do in the examples. And then the conditions are slightly different. The conditions to perform this test are, number 1 is the same, random. Your data has to come from a random sample, no different. But 2 is really different, so I'll put a star by it. For 2, instead of the normal condition, what you're going to check for is that you have, it's called large sample size, a large enough sample size. And what it means is that all the expected counts have to be at least 5. And you actually have to compute them and show that, which you need to compute to find chi-squared anyway. So all expected counts have to be greater than or equal to 5. That's your number 2 condition, large sample size. And 3 is the same, independent. Independent. So that's like the 10% condition. 10% condition.